So, hello guys, what's up? So, here we are again continuing the series of Project Euler. So, let's start with the second problem where we have left the last time. Okay, what was the okay? So, before starting the to code the solution, we will let's find what exactly the question was. So, here is the question statement. Each new term in Fibonacci sequence is generated by adding the previous two terms. Okay, we know that. So by starting with 1 and 2, the first term 10 terms will be like this given. Okay, what we have to do is by considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even value terms. So like we have, I think we have to and some of the elements like the 2 plus then 8 plus 34 plus then 89. I think this will be the like challenge. We have to find the sum like this given the limit does not exceed 4 million. So let's start with our logic. Let's get to the code editor. I am using VI here in Ubuntu. Like I prefer this, much simpler, not anything more stuffs to handle. Okay, so let's start. Let's include the libraries. I think we will require a lib. Okay, so the challenge was like the limit was for like 4 million. Yeah, so let's define a constant. I like to do the defining this way. If you want to like make it as a long integer or something, you can do that way. Okay, then let's make a function for this, which I will call it as Fibo. This is the declaration, and let's code the logic. I will explain the logic while going along coding. So let's first declare the variables. I think we will require one variable for loop, one for the storing of the sum, and I think we will be requiring two or three, I think two more integers or long integers to like I think swap the values, the even values in the continuation with the series of the sum. So if we require more, we will declare some more and we will then go forward. Let's initialize here itself. The second will be, I think, 1. Yeah. And let's define the next equal to 0. Let's define the I and some. Let's initialize sum with 0. So taking the help of for loop, we will be running the for loop until the max size, that is the limit. Plus I'm coding little bit slow, so you can cope up with my process of explaining. Uh, then what will be the condition? The first one will be to find the even. Mm, some of the even. So yeah, first will be to find the even. Let's take integer f long f2. Sorry, not integer. It's long. Then let's find out if it is even or not. If it is the even one, we will add it to our sum. Uh, yeah. Then let's swap those variables for the next sum. Oh, sorry, it was f1 plus f2. Then let's swap it equal to, and then f2 equal to next. And then if f2 is greater than size, then we will get out of the loop. That will be the end condition. And I think it's pretty much it. Okay, we'll just return this value of sum. Let's define our main where we will call this. So I think there is no need of declaring again a variable, storing the sum in it, and then printing. Let's directly print it. This will be long. C2 was the function name, and okay, let's try to run it. So cc, let's check all those warnings if any is there by mistaken. I think there is no warning, so like we can proceed. What? No such file or directory. Okay, I think I missed. Okay, it will not be q2, it will be q, but let's compile it with q2, so the process remains the same, just the file name changes. What? So let's check our logic again, where we have gone wrong. Is this 4 million exactly? I think yes. F1 start with 0, F2 with initializing with 1 perfect, and then next equal to 0. Okay, I sum, what is showing 0? Okay, so I think you might have got what was wrong. We are adding 0 every time. in the sum, so it will remain 0 all the time. Let's add f2, which will be the even integer in the series. So let's again compile and run it. Compilation, no error. Let's run it. Okay, so we have the answer 4613732. So let's put the answer, or like let's verify it by ourselves. Let me hide my screen for a second so that anything private or something don't get leaked. Okay guys, I like I have hidden my answer beside like, do you think this is correct? Let's check it. I will reveal it slowly, and tada, our answer is perfectly correct. And here we go again to our logic. Here is our logic. If you haven't understood anything in this logic, it is pretty, I think, pretty simple. Let me explain it again to you. So there was a and condition that was saying the limit should not exceed 4 million. So we have taken it, defined it in the term of size, a constant variable which has the value 4 million in it, and we then have defined a function fibo, and in that we have declared few variables like f1 and f2 was like to store those previous and the next element in the series, and like next was the third element, which was basically storing the sum of the two and storing it in next, and like we used basically three variables to swap the values, and I is just for the loop, and sum is to so store the sum of all those positive, I think sum in that Fibonacci series. And here is the loop running from I equal to 0 to the size, which is 4 million. And if the element like f2, which we have considered here, when divided by 2 gets 0, so that's basically logic to find a even number. So if that number is even, so then we were adding it to our sum, and like then storing the sum of f1 and f2 in the next, and just swapping the f1 and f2 variables with the value of next and f2. And like we have to get out of the loop uh, pretty soon when f2 gets bigger than size. So here we break the loop if f2 gets bigger than the size, and after getting out of the loop we get the sum of all those positive numbers, and then we return it to a main function from where we call this Fibo function. I haven't declared any more variable in the main function, because we were already returning the sum which was required and nothing fancy to do it there. So I directly printed the sum of the series which was asked, and that is the answer what we got here. The answer is 46137, which what we got in our program. So like this was the solution, my solution for the second question. There might be few others who might have got like really good solution than me. Might be their time complexity or space complexity would be good, or the logic might be better, but uh, I have gone through this logic because I thought it was more convenient and easy to understand. So yeah, that's it. If you face any difficulty, you can comment down in the section and we can go through it. I think that's it for this video. Let's meet you in the solution for the third question in the series. Until then, take care. Bye bye.